We want to differentiate 1 over the cube root of x squared plus 3. So begin by letting y be equal to 1 over the cube root of x squared plus 3. And using our knowledge of indices, we can write this as x squared plus 3 to the power minus 1/3. This is still y, since we haven't differentiated. Now let u be x squared plus 3, and then y will be equal to u to the minus 1/3. Differentiating du dx is equal to 2x. dy du is going to be minus 1/3 u to the minus 4/3. Now forming a chain, dy dx is going to be equal to dy du times du dx. So dy dx is going to be equal to minus 1/3 u to the minus 4/3 multiplied by 2x. Dealing with the numbers, we're going to get minus 2/3, then we have x, and the u to the minus 4/3 will be x squared plus 3 to the minus 4/3. We have differentiated, but we could tidy this answer further. We can look at things that are genuinely on the top, which is the minus 2x, and things that should go to the bottom. The 3 is there already, and the x squared plus 3 to the minus 4/3 goes to the bottom as x squared plus 3 to the 4/3. If you look at the expression I have, this is x squared plus 3 to the 4/3. We have an x squared plus 3 to the 1, and an x squared plus 3 to the 1/3. And 1 plus 1/3 is 4/3. This last tidying step is unlikely to be worth any marks in the exams. Occasionally, they will give you a target, an expression that you should show dy dx is equal to. And if it were this expression, you should be able to see that you could get here from the line before. However, it is the line before that really is being examined here, because when we reach the line before, we have differentiated. Now let's use the second way of applying the chain rule to this problem. We can see here that the inside function is the x squared plus 3, and the outside function is x to the minus 1/3. So differentiating, we get minus 1/3 times the bracket to the power minus 4/3. We times by the differential of the inside function, which is 2x. This gives us minus 2/3 x times x squared plus 3 to the minus 4/3, and we have differentiated, and now we could tidy, which I'm just going to do to give me the same expression as we had in the first part of the example.